Welcome to this session for Algebra 2 on Systems of Linear Equations, Part 1. What we're going to accomplish today is we're going to be determining whether an ordered pair is a solution to a system of linear equations with two variables, and we're going to solve systems of two equations with two variables by graphing, substitution, and elimination or linear combination. What is a system of linear equations? Well, I'm glad you asked. It's a system that contains two or more linear equations that are being solved simultaneously. A solution of a system in two variables is an ordered pair that makes both equations true. You do have three possible outcomes when you're working with a system of equations. You could have one solution, which would be the ordered pair, no solution, or an infinite number of solutions. Remember, if you need to pause the video, you can do so in the lower left-hand corner. There are three ways to solve a system of linear equations: graphing, substitution method, and elimination or linear combination method. So I'm going to take one problem and do that problem with the three different methods so that you can see all three. And then we'll end with two problems that I'm going to use the elimination method for. I will also show you how to do one of those problems on the graphing calculator. So solve the system of equations, and we're going to do it by graphing. So what we need to do is to graph both lines. So depending on which choice you prefer to use for graphing, you could make a table, you could find x and y intercepts, you can use slope-intercept form. The second equation is slope-intercept form, so I would suggest using that one. The first equation is in standard form, so it's easy for us to find the x and y intercepts quickly. So let's write them down here. X plus y equal to 5. If we find the x and y intercepts to graph it, to find the x-intercept, remember we make x equal to 0, or I'm sorry, y equal to 0. And when y is 0, we get x equal to 5. So I have an ordered pair at 5, 0. And then to find the y-intercept, I make x equal to 0. So it will be y equal, sorry, that's getting a little hard to see, y equal to 5. So my y-intercept is at 0, 5. So if I graph these over here on my graph, it will be 5, 0, which will be right here, and 0, 5. So if I connect my dots here, let's see if I can get a straight line. Okay, so it's somewhat straight. That's x plus y equal to 5. Then if we do y equal to negative x plus 3, I can do a table if I want. I can do x and y intercepts. I can use the slope and the y-intercept. I'm going to use the slope and the y-intercept here. The slope, sorry about that, is negative 1 over 1. And the y-intercept is at 0, 3. So if I graph 0, 3, it's right here on my number line. I'll try yellow here, maybe that'll show it better. 0, 3, and then slope go down 1 and over 1, down 1 and over 1, down 1 and over 1, and we get more points for our graph. So this point is at 3, 0. Connecting the points gives me a line that looks like this. So what we notice here is that the lines are parallel. So when your lines are parallel, that means that you have a no solution. The graphs don't intersect anywhere on the graph. So the lines aren't intersecting, so we have a no solution to this system of equations. So they aren't intersecting anywhere, they are parallel to each other, so it's no solution. Now, moving on to if we try that same problem using substitution. Substitution, in order to use substitution, one of your equations has to be solved for either the x variable or the y variable. So I use substitution when one of my equations is already solved for a variable. So if I look at the system and I see that one of the equations is solved for a variable, then I use substitution as my method to find a solution. So what we do is we take the expression that your variable is equal to, and we substitute it into the other equation. So what I'm going to be doing is I'm going to be taking negative x plus 3 and replacing the y with that expression. Now why do we do that? Well, we do that so that we can solve for one variable. So I'm going to take the negative x plus 3 and I'm going to replace the y. So I will have x plus, and I'm replacing this y with negative x plus 3. So I'll have negative x plus 3 equal to 5. So again, I'm taking one expression and replacing it in one of the equations. So I'm taking the negative x plus 3 and I'm replacing the y with that whole expression. And then I'm just going to solve for x. So x plus negative x is 0, and I get 3 equal to 5. Well, that is not a correct statement. So that indicates that I have no solution. And we know that from, we just did the problem with graphing. So when you get a false statement like this, your variables cancel out and you get a false statement, it's a no solution. And we kind of worked where we saw no solution before when our variables canceled out. If your variables cancel out and you have two things, a correct statement like 0 equal to 0, then it is an infinite number of solutions. All right, let's solve the same problem using the elimination method. For the elimination method, both of your equations need to be in standard form. So let's write that down up here. Okay, so both equations must be in standard form to use the elimination or linear combination method. So what I need to do then, in order to use the elimination method, is change my second equation so that it's in standard form. So my second equation in standard form will be to add the x to the left side. So I'll have x plus y equal to 3. I have to add the x to the other side of the equation. So now what I have is x plus y equal to 5 and x plus y equal to 3. So when I'm using the elimination or linear combination method, what I'm trying to do is to cancel out two variables that are the same so that I can solve for the other variable that's left. So what I look to do is to multiply either one or both equations by a number that will give me opposite coefficients in front of either the x variables or the y variables. So basically you have to decide which variable would be easiest to eliminate. Well, in this situation, this system of linear equations, it doesn't really matter. There isn't one that's going to be easier over the other. So I'm going to choose to eliminate x. So I'm going to work on eliminating x, which means that their coefficients both are 1. So I have the same number in front of x, I just need them to be opposite signs. So I'm going to multiply the second one, and it doesn't matter which one I do, by -1. Now there's different ways to do this, but to keep it consistent, I'm going to always add my two equations together. So that means that I need to multiply the bottom one by -1 so that the coefficients in front of the x's are opposite. So on the top, I have x plus y equal to 5, so I want to put the 1 there. And then on the bottom, I have negative 1 times 1x is negative 1x. Negative 1 times y is negative y. And negative 1 times 3 is negative 3. So when I add, our next step is to add. After you multiply by a number to make your coefficients opposites, you add the two equations together. And adding them together, 1x minus 1x is 0. Y minus y is 0. So I get 0 equal to 2. That's an incorrect statement, so that also indicates, once again, that this is no solution. So that's how you use the 3 different methods. For our last 2 problems, I'm going to use the elimination method. I like the elimination method best of all, our linear combination, but you can use any of the 3 methods when you're solving a system of linear equations. So here we have this system, 2x minus 3y equal to negative 2, 4x plus y equal to 24. Now, if both equations are in standard form, the elimination method is probably your easier method to use. If one of them is solved for either the x or y variable, then substitution may be easier for you to use. But as I said, I'm going to use the elimination method. So what I need to do is decide, do I want to eliminate the x variables or do I want to eliminate the y variables? Which would be easier for me to do? So I have to make a decision on which variable I want to eliminate. So in looking at them, the y variable has a coefficient of negative 3 in the first equation and a coefficient of 1 in the second. So if I multiply the second equation by positive 3, that will give me opposite coefficients in front of the y variable. So I'm going to multiply the second equation by 3. So my top equation remains the same. And my second equation becomes 3 times 4x will give me 12x. 3 times 1y will be a plus 3y. And 3 times 24 will give me 72. Now, our second step again is to add them together. So your first step is to decide what variable you're going to eliminate and then multiply by whatever number you need to multiply by to make the coefficients opposites. Then you add the two equations together, eliminating one of the variables. 2x plus 12x gives me 14x. Negative 3y and positive 3y is 0. Not 0y, just 0. So the y is gone. That was our goal, to get rid of the y variable. Negative 2 plus 72 gives me 70. Divide both sides by 14, and I get x equal to 5. So I'm only partly done, because remember we said the solution to a system of equations, a system of 2 equations, is an ordered pair. So I have the x part of my answer, so I'm going to list it up here. Now I just need the y value that makes this system of equations true. So I can easily find that by taking this x value and substituting it into the original equation for x. And I can choose which one I want to substitute it into. It doesn't matter, you should still get the same answer. So I'm going to substitute it into the first equation. So I'm going to substitute the x into the first equation. So I get 2 times 5. So the 5 here is being substituted into the first equation, minus 3y equal to negative 2. Now why do I do that substitution? So I can find the y value. 2 times 5 gives me 10, minus 3y equal to negative 2. Subtract 10 from both sides, and I get negative 3y equal to negative 12, and y is equal to positive 4. Dividing both sides by negative 3, negative 12 divided by negative 3 gives me a positive 4. So I get an answer of 5, 4. That's my solution to this system of equations. Now the good thing is you can always check your answers, because you can take these values, 5 and 4, and substitute them in for x and y in both equations and make sure that you get the negative 2 and the 24. And if you check that, you do get negative 2 and 24. So I know that I've solved it correctly. Now, if we're going to do this on a calculator, there's some extra steps that we need to take if we want to solve this on a calculator. If you're going to solve it on a calculator, you'll notice that on the graphing calculator, there is a y equals button, and I'll show you that shortly. I'll show you on the actual calculator. But that means that if we're going to put an equation into the calculator, it has to be solved for y. So if you want to do this on the calculator, your equations must be solved for y. So let's write that up here. Your equations must be solved for y. So if I take 2x minus 3y equal to negative 2, and I solve it for y, I'm going to go down here and type the other one in quickly. I will be subtracting 2x from each side. So subtracting 2x from each side gives me negative 3y equal to negative 2x minus 2. I'm subtracting the 2x. Now, to finish solving for y, I divide both sides by negative 3. So when I divide by negative 3, that gives me y equal to negative 2x divided by negative 3 minus 2 divided by negative 3. So that gives me an equation of y equal to positive 2/3 x plus positive 2/3. The negatives become positives. So that's my one equation that I'm going to put into the calculator, and then the other comes from the 4x plus y equal to 24. I have to subtract 4x to the other side to solve for y. So I get y equal to negative 4x plus 24. So these are the two equations that you want to write down right now to put into your calculator. So I'm going to bring up the calculator right now. And you want to make sure your calculator is on, and you want to hit y equals. So for y1 equals, I'm going to put the first equation. Now what I'm careful to do every time that I enter an equation into the calculator is any fractions, I always put them in parentheses. So 2, parentheses, 2 divided by 3, divided by 3, parentheses, then x is right next to the green alpha key, plus, parentheses, 2 divide 3, parentheses. Then you can arrow down or hit enter to get to the y2. Enter is your bottom right blue key. y2 will be y equal to negative 4x plus 24. Make sure you're hitting negative and not minus when you're putting the negative 4x in. Then you're going to hit graph. The graph is the upper right-hand corner. And you can see that these two graphs do in fact intersect each other. So how do I get my solution? Well, what we do is you'll see calculate across the top in yellow. It's above the trace key. So I'm going to click on second, which is yellow, because I want to do the calculate function. So I hit second, trace, and I go down to intersect. So I click enter on intersect. And now I have this flashing cursor and all this information on the screen. you want to use your right and left arrow keys to go up to where it looks like the two graphs are intersecting each other. So I'm going to use my right arrow key, and you can see that my cursor starts moving. So I go all the way up to where I think the two graphs are intersecting. And you can see in the upper left corner it tells me what line I'm on, the 2/3 x plus 2/3. So I hit enter, and now you can see that it's saying I'm on the line negative 4x plus 24. I don't need to move my cursor at all. I can just hit enter again. And now it's saying move it around if you want and make a guess of where the intersection point is. So I never move it. I just hit enter again. And it tells me that the intersection is at 5, 4. And that's what we got doing it algebraically. So that's how you can do it on the calculator to find your answer as well. So again, one last time, it's second trace to find the intersection point. So we hit second trace, and we went down to intersect. And then you move your cursor around till you get to where you think the graphs are intersecting, and you hit enter 3 times, and it shows you the intersection point. Okay, so we're going to do one last problem using elimination or linear combination method. 5x plus 3y equal to 30, 2x plus 3y equal to negative 3. They're both in standard form, and you can see that I have the same coefficient in front of the y variable. So that tells me eliminating the y variable would be the easiest. All I need is for them to be opposites. So I'm going to multiply the second equation by negative 1 so that I have opposites, or positive 3, negative 3, in front of my y's. So the first equation remains the same. Second equation becomes negative 1 times 2x is a negative 2x. Negative 1 times 3y is a minus 3y. And negative 1 times negative 3 gives me a positive 3. Add the two equations together. 5x minus 2x is a 3x. 3y minus 3y is 0. And 30 plus 3 is 33. Divide both sides by 3, and we get x equals to 11. Now I take that 11 and I substitute it into either the first or the second equation for x. I'm going to do the first one. So I will have 5 times the 11 plus 3y equal to 30. 5 times 11 is 55. Subtract the 55 from both sides, and you get 3y equal to negative 25. And my last step would be to divide by 3. So sometimes we do get fractions, guys. That's going to happen. I would leave it as an improper fraction rather than changing it to a mixed number. So we get y equal to negative 25 thirds. So my solution here is 11 and negative 25 thirds. So I can substitute those into both equations to check my answers, and you'll see that those two answers do in fact work. So that is my solution to this system of equations. And that ends this session on part 1 of the systems of linear equations.